Good afternoon. This is Rich Nass. I am the Executive Vice President of Open Systems Media, and I am here for this week's installment of 5 Minutes With. This week, I have the pleasure of speaking to Tim Saxe, who is the Senior Vice President and CTO of QuickLogic. Good morning, Tim. How are you?
I'm good. How are you?
I'm just fine. Thank you very much. Okay, so you're with QuickLogic, and you guys are into the wearable space. That's a pretty crowded space, and I'm sure I don't have to tell you that. So without getting too promotional, how do you differentiate yourself in this very crowded space?
Well, most people in this space are looking at the exciting area of data analytics and apps that take wearable sensor data and provide insights into things like sports and activity levels and sleep quality. And what all of these people have in common is that they need hardware to gather the sensor data and ship it to the cloud. And the challenge they have doing that is how do you do that without killing the battery? How do you keep good battery life? So what we do is we actually provide hardware, software, and expertise to enable them to create these sensor devices they need and have exceptional battery life for those devices. And a good example, recently Runtastic released their Moment Watch. So this watch gathers all of the data you'd expect, activity and sleep and so on and so forth, and has a 6-month battery life. And that's the kind of thing we want to enable.
Okay, I'm going to ask you to go a little further down that road. How do you enable a 6-month battery life? You can get a little technical with me.
Yeah, that's fine. It's actually an interesting thing. So the world has moved to the place where everybody uses little computers, MCUs, to do everything, and software is the flexible standard that everybody uses. The challenge with software is it uses more power than hardware. So what we decided to do was to build a small coprocessor to go along with one of these general-purpose CPUs. And the coprocessor is a sort of micro DSP engine that processes the sensor data, manages the sensor, and processes that data. And it can do that at maybe 1/10 the power that you'd normally have with an MCU. So this coprocessor working in conjunction with an MCU gives you significant power savings and yet still the flexibility of the MCU to do what you want to do.
Okay, fair enough. Is that MCU based on some other architecture like an ARM?
Yeah, we use an ARM MCU because that's that's the standard in the world today, essentially.
Yep, absolutely. Okay, so that brings up a subject. When you're in wearables, you have people's data, and people are very concerned about their data and the security. I know whenever I bring up these subjects, it's always the forefront. Is that your problem, keeping somebody's data secure, or is that a pass-through to your customers?
Well, the data is passed through to our customers. I think ultimately we should play a role in that. The reason why I think you need to play a role in that is you really can't have data security without hardware support for that. The ecosystem doesn't really have that today, but it's coming along, and I think that'll mostly be driven by ARM.
Okay, fair enough. Okay, so now let's go back to the information that's being generated. There's a huge amount of information that's coming off these devices, wearables in particular. I know, I have a device that I track how many steps I take and all that other good stuff. How do we make sense of all this huge amount of data?
Yeah, that's a good point. So that really comes from domain experts who understand, the things that are important to people. So we view our role as sort of helping them crunch that data and get it down small before it gets sent up into the cloud, because that's the energy inefficient part of the process. So I think you're going to see a couple of things. I think you're going to see, first of all, people who are domain experts, like cardiologists, playing a role in analyzing this data. And then the other thing you're going to see is big data and machine learning, because that's one of the best ways of crunching on large data sets. Of course, the problem with that is now you have to share data sets among people, which then gets back into that privacy concern you had in the first place. But ultimately, what we believe is a lot of this activity will happen on the edge, And the edge is, in our case, right in our little CPU, where we'll take the data, we'll maybe implement some form of machine learning kind of thing, and crunch that data down to the insights you want, and that'll all be handled out in the device.
Okay. Is there something on the horizon that's revolutionary? Maybe not from you guys, because I know you don't want to talk about that. Is there something that's going to change wearables going forward? Maybe pulling energy from the body, or we've talked about for years and years. Anything like that you foresee coming?
I think the real revolutionary thing will come more on the side of bringing in data measurements of things that people care about more. So if you think about it, if you ever have the unfortunate situation of being pulled into an ambulance, they don't ask you how many steps you took. They ask you what your blood pressure is, and they take your heart rate and look at your respiration rate. So I think that the missing element right now is we're unable to measure the critical elements that affect our lives. And with new sensors coming along, I believe that's going to be possible in the next year or so. And then the wearables will be much more relevant to people. They'll see the purpose of them.
That's a really good point. Wondering why we don't have that already. It doesn't sound like it's that hard to do.
Maybe it's a little harder than we think, but it's a good question.
Very good. Okay, well, our 5 minutes is up, Tim. The 5 minutes goes really fast.
It certainly does.
I'd like to thank you. That was Tim Saxe, the Senior Vice President and CTO of QuickLogic.
Thank you.
Have a good day.